So this is a quick demo of the image caption generator model that I have on my portfolio. So how does this work? What technologies are behind this image caption generation approach? So first of all, we have a two-branch machine learning model that was created on Keras with TensorFlow backend, and one branch takes in input features of the image. So what we do is that we pass the image into a VGG16 architecture and we extract the features, and we pass those features um, after, of course, extracting all of the image features. So we are using the Flickr 8K dataset here, 8,000 images, each with 5 descriptions. So we pass in each image and we pass in a summary, and what we are expecting as a target is that the model would predict the next word in the summary. So without further ado, let's dive deep into it. So before beginning, we will set up a few things uh, to help us get going if we are using Google's Collaboratory or using your own local machine. We will set up some variables, import our Google Drive, mount our Google Drive, and that's all for that. So we will do some basic imports um, that we see usually on a typical machine learning project. Then we will extract features from the images. So what this thing is doing over here is that it is going to take in images, and using the VG16 architecture, it is going to extract the features from those images, i.e. it is going to take the um, topmost layer, remove it, and then the second last layer that we have, we will use its activations, its output activations, and we will return them. And this is going to take a lot of time. It's going to take 30 minutes on GPU, so I'm not going to run it. Next up, we will do some basic data cleaning. We're going to remove uh, unneeded words, stop words. We're going to be cleaning the descriptions. So next up, we will create tokenizers. So this will convert the English text into vectors that the model can understand, and we're going to be padding those vectors with zeros. So there we go. Next up, we will define the model. So like I said before, we have two branches. It's a two-branch Keras model. The first branch takes the features that we had extracted from the VG16, and the second branch takes the entire summary, and we will pass it parts of the summary, and we will provide as targets the next word in the summary so that it learns to predict the next word in the summary given that input feature of the image. So we will summarize the model, and then we will create a data generator because we know that this is going to be a lot of data. So we have created here a create sequences function, and then we have created a data generator that uses that create sequences function to generate batches of images and their corresponding targets, and also the part of the summaries that we're going to be feeding to the model. Next up, we will fit our model finally. So we define the generator, and we compile the model with Adam with a learning rate of 0.00005 and with a loss of categorical cross entropy, and we fit the model finally for 31 epochs. So this is going to take a lot of time even on GPU, and I've changed a few things a bit because if you do this without making these specific tweaks that I have made, then you're going to run into a few problems. So that's why I've done this. And we evaluate the model, and we evaluate it using blue scores. Now if you don't know about blue scores, you can read about them. They are used to evaluate machine learning models that are doing machine translation. So a blue score of a 1 means that your model has perfectly uh, you know predicted the output sequence as was given in the um, target target database that we had, and that is impossible for even a human translator or a human text summarizer. So a blue score of zero point 0.7 is very good. It's part of it, it's state of the art. With 8,000 training examples, uh, a test blue score of 0.50 and blue 2, the difference between blue 1, 2, 3, and 4 is that blue 1 takes into account um, one bag, it takes into account each word, and the blue 2 takes into account a bag of two words. So it is going to match pairs of words uh, in the predicted results and in the original targets. And similarly, blue 3 takes a collection of three words, blue 4 takes a collection of four words. So these are the results. We save everything up and let's see the model next in action. So we will use a few images that we have put in our working directory. For example, an image of a dog that I will show you here, and the model predicts it. Uh, I have already run these cells, so the image will be shown to you here. So let me open the file manager, the project directory, and this is a dog. So it's essentially a white dog with a black nose and black eyes running on the grass, or I must say, he's not running, he's just, enjoying his time. So when we ask the model to predict this, it gets things right. I mean, close to right. So it predicts start seek black and white dog is running through the grass. So that was all for today. I hope you liked this and see you in the next demo.